All right, we're doing section 13.2 now with ellipses. Ellipses are very similar to circles. In fact, they're just ovals and just squatted down a little bit, but the equations are a fair bit different. The interesting thing about ellipses and hyperbolas both is the equations, once they're in a nice standard form, will always equal 1. So that means all of the good stuff happens on the other side, the left side. We still have our x minus h and y minus k. Both of them are squared. Both of them are positive. But what we have is these fraction ideas. And the a squared and b squared are numbers that describe the length, width, and height of our ellipses. Ellipses could be either horizontal or they could be vertical. Let's not talk about the slanted ones, we won't worry about it. But if they're horizontal, that means the number along with the x is going to be larger than the number along with the y. And similarly, if it's a vertical, the larger number is going to be with the y, and the smaller number is going to be with the x. So for ellipses, A is always greater than B, so you can tell immediately what an ellipse is, horizontal or vertical, based on the equation, as long as it's in this standard form. For instance, this one right here, because it's nice, clean, parentheses, divide with fractions, this number is larger, that means it's vertical. So now what do these numbers A and B actually mean? Well, let's go ahead and sketch this real quickly, and then we're going to do some Desmos, which makes things a whole lot easier. But I know that my center is 3, -1, right? 3, -1. And my major axis is 2a. My minor axis is 2b. In this case, a is 7, the square root of 49. So that's 2 times 7 equals 14. And my minor axis, square root of 16 is 4. That's 2 times 4. That's going to be 8. So now, let's go ahead and graph this and see how it looks when I graph it. Well, my center is 3, -1. I'm going to have to do it over here and then end up erasing it probably. 3, -1. There is my center. And now my major axis, because I know that this is vertical, is 14. That's just 7 up and 7 down. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And my minor axis is 8. That's 4 over this way. 1, 2, 3, 4. And 1, 2, 3, 4. And now those are the boundaries of my ellipse. And they're a whole lot easier to draw in your head than they are for reals. But that's the idea. So that means you could end up looking at a graph and saying, whoa, this is 4 this way and 7 this way. That means 16 goes with the x, 49 goes with the y, and this thing's been shifted over and down. You've got all the pieces you need to build the equation from the graph. Now, let me give you an example of an equation here. Let's say they ask you to graph something like this. First of all, you notice a couple of things. There are no fractions over here. This isn't 1. There's a number up here with it. You could go through and do a fair bit of divide everything by 16. Wonderful. You could do that. And when you divide by 16 over here, 16 with the 4 reduces to a 4th. That means in the y direction, the square root of 4 is 2. You're going to have an up and a down of 2. Over 16 over here, the square root of that is 4. You're going to have a 4 in this side and this side. Or, again, just graph it. I've got it turned off right here. You graph this thing, and there you go. You can see where the center is. The center is 1, 2, 3, 4, 5. 1, 2, 3. This is -5, 3, right? Oh yeah, -5, 3. And you can see the major axis is a total of 8. Minor axis, a total of but you could certainly go through and pick the correct absolute value for that. So that's how this stuff works. Play around with it. Send me an email if you have any questions about it. You guys are great.